An important concept of securing our applications involves hashing passwords, and this video is going to focus on that concept. The problem with plain text passwords is that they are readable, and if we were to store that readable information, it's very easy then to work out what someone's password is. All we have to do is to gain access to that data, and then we can just read it. And over recent years, hundreds of millions of account passwords have been stolen. To avoid this kind of problem, we really must encrypt passwords. To encrypt a password is fairly easy to do these days. We use an algorithm to encode the plain text password, which makes it much more difficult to guess, but not impossible. Part of the problem is that some encryption algorithms have been broken, which means that it is very easy to work out what the plain text password is. And if you want to know which algorithms have been broken, you could do a search for something like broken encryption algorithms, and you'll be surprised at just how many encryption algorithms have actually been broken. Part of the problem is that as computers get more and more powerful, they can run much faster and do a lot more work in much shorter times, and that makes it easier to break encrypted passwords. Some of the ways in which passwords can be cracked are just to make a guess based on information you might know about a person or an organization. Or you might take a dictionary of words and use those words to compare against the user's account that you're trying to crack. A combination of that kind of thing is to use a brute force attack, where an algorithm will invent passwords either through random guessing or a word list, and then will very rapidly compare those words against the user account, trying to get the correct password. And this is where the speed of the computer is really helpful, because the faster the computer can do this, the sooner the password can be cracked. There are other approaches as shown here as well. Now, when we're trying to encrypt in Java, there are various algorithms we can use, some of which ship with Java. Others are provided by third-party libraries. In this example, we're going to use the PBKDF2 algorithm to encrypt a string. I've called this string password, and we end up with hashed password, but it doesn't have to be limited to a password. This could be any string that we want to encrypt. Rather than me explain line by line what this does, it's probably just enough to say you can copy that code, paste it where you need it, change the names of the variables to something that is meaningful, and there you have an encrypted string. For reasons we've already noted, cracking encrypted passwords is not impossible, and so what we might want to do is encrypt the encryption. If we hash a password and hash it again and again, that will make it more difficult to guess, because the program that is trying to guess won't necessarily know how many times the plain text password has been encrypted, and that will make it more difficult. If we're able to use a random number of times to encrypt, that makes it even more difficult. But of course, it also makes it more difficult for us if we don't remember how many times we have encrypted. So it would be important to store, along with the encrypted password, the number of times it has been encrypted, so that when we want to compare a user's password, we can encrypt it the same number of times as the one that we've got stored in the database before we make the comparison. So it is very important that we remember exactly how the encryption has been done, because that user password, when the user is logging in, will need to be hashed in exactly the same way as the value that we've got stored in the database. Otherwise, that correct password will never be valid if we encrypt it in different ways. So when should we encrypt passwords? Well, pretty well every time. First of all, when a user registers, they provide a new password, and then we want to encrypt that new password before storing it in the database. whenever a user authenticates, we will encrypt the provided password, then retrieve the user's password from the database and compare the two encrypted passwords. And the reason we have to do it in that order is because an encryption is a one-way street. We can go from the plain text to the encrypted password, but we cannot decrypt the encryption to arrive back at the plain text. Because it's a one-way street, we have to encrypt the plain text that we are given when a user authenticates and compare the encrypted authentication password with the encrypted registration password. Now, there's a lot more that you can find out about encryption algorithms in Java and indeed other languages, and so it would be well for you to do some additional reading on this topic.